In JDK 21, a powerful feature called virtual threads was introduced, and with version 3.2, Spring Boot has support for it. In this video, we will see how we can enable our new or existing Spring Boot projects with virtual threads with literally no coding and take advantage of some of the concurrency benefits which virtual threads bring. And then demonstrate how they increase concurrency or performance with a performance test. We will use the example when a Java client has to call a REST API service, which would take some time to complete. So we will create two apps, a REST API service and a REST client to call that service in order to demonstrate the performance improvement with the virtual threads. I have made a video explaining virtual threads in Java. Please watch it if you want to learn about the concurrency model in Java and how virtual threads help with overcoming the limitations and scaling our application. In short, every request in Java uses a thread, also called a platform thread, which is a wrapper around OS threads. So the number of concurrent requests is limited to the number of OS threads available. So when blocking jobs like writing to a file, calling another service blocks a thread, other concurrent requests have to wait for that thread to complete. Virtual threads remove the one-to-one relationship between platform threads and OS threads, giving us virtually unlimited virtual threads which map to platform threads and help us scale. Please watch that video for more details. Let's first start by creating a REST API. Let me go to start.spring.io website. We will use Maven, Spring Boot 3.2, give our name REST API, add the web dependency, and click Generate. Here is the downloaded zip file. Expand it. Let me start IntelliJ. Click Open, browse to our expanded folder, point to the pom.xml file and click Open. Open as project, trust project. Let's go to our Java package. Right click and say New Class. Give it a name controller.demoController. IntelliJ will create a package controller and inside it a class demoController. Let us mark it as a REST controller. Create a get mapping with the /test URL path. Inside the method public string test, let's just print sleeping for 2 seconds and call thread.sleep, passing in 2000 milliseconds or 2 seconds to sleep. This is to simulate a situation when the service takes some time to complete when called by a client. Return success. Handle the exception. Let me go to the main class and start the app. It starts on port 8080. Going to the browser, let me type http localhost 8080/test, and with a slight delay, we see success. So our REST API, which takes some time to complete, is up and running. Now let's create a REST client to demonstrate the virtual threads. Go to start.spring.io. Let's give it a name REST client with the web dependency and click Generate. Save it in the same location. Unzip the file. Go back to IntelliJ, click Open Project. Navigate to the pom.xml file of the REST client and say Open. Trust project. Open in a new window. Go to the Java package node and right click and say New Class. Call it controller.callRESTService. So IntelliJ creates a class called REST service inside the controller package. Mark it as a REST controller. Create a get mapping of /call. Create a method public string call API. Inside it, create REST template instance RST as new REST template. Create a string variable RET as rst.get for object and pass in the URL for our REST API, http localhost 8080/test, with the second argument as the return string parameter string.class. Using system.out.println, let's print thread.currentThread toString to print the thread details, and let's return that to the calling client. Since our REST API is already running on port 8080, let's go to the application.properties file and change the port to 8888. Let me put the parameter spring.threads.virtual.enabled equal to false, which is its default value. So the project will run the traditional Java way using the OS threads. Even if I had not put in this parameter, that would have been the behavior, but I just wanted to put it now so that we can observe the behavior with the traditional way first, and then we will switch it to true to see the behavior with virtual threads. Now typically the number of OS threads is limited by the core of the computer you are running it on, and we do not have to specify this parameter, but for the purpose of our test, let's say our computer can have a maximum of 2 OS threads. So by using server.tomcat.threads.max equal to 2, we are limiting to a maximum number of 2 OS threads. Okay, let me start the REST client now. It starts up on port 8888. Going to the browser and typing http localhost 8888/call, we invoke the client endpoint, which returns back the thread used by the client to call the REST API. We can see that it used the OS thread with the main keyword here. Now, if I enable the virtual threads by setting this to true, stop and rerun the app, go back to the browser and run it again, we see now that the client uses a virtual thread. Cool. Alright, we now know how to enable our project for virtual threads. Let me go back and set it to false again. Stop and rerun the app. Now, for the performance test, we will use a tool called Apache Benchmark, which is installed by default on Mac OS and most Linux distributions. Apache Bench is not natively available on Windows, but it can be installed through third-party packages like XAMPP or Apache Lounge. Alternatively, it can be run on the Windows Subsystem for Linux (WSL) by installing it like on the Linux distribution. You can use some other tool like JMeter also. Okay, let me open up a terminal window. Apache Benchmark can be invoked by typing AB. It gives the usage options. So using -n, we can specify the total number of threads, -c for the concurrency level. Alright, let's run our baseline test first with -n. Let's say we want 20 threads. Let's say we want 20 requests to be submitted simultaneously. -c for concurrency, let's say 1. And put the URL for our REST client, http localhost 8888/call. Now each request would take 2 seconds, which is the thread sleep time we had put in the REST API. So with 20 requests and a concurrency level of 1, we should expect one request to go at a time, taking a total of 20 times 2 or around 40 seconds. And we do indeed see around 40 seconds as total time. Let me increase the concurrency level to 2. We have configured our Spring Boot project to simulate a system which can handle a maximum of 2 OS threads, so this should cut the time in approximately half. And we see around 22 seconds. Apache Benchmark probably does not capture it accurately, or there might be some overheads to the time and it may not be exactly 20 seconds. Alright, let's now run it with a concurrency level of 4. But since we have limited Tomcat max threads to 2 to simulate an OS having a limit of 2 OS threads, it will still be able to only process 2 requests at a time, and the time will still be the same, around 20 seconds instead of the 10 seconds. Alright, now let's get back to our Spring Boot project. Here in the console, you can see only 2 threads processing the requests, and these are the main or platform threads. Let me enable the virtual threads. Stop and rerun our project again. Running our test with a concurrency level of 4 again, now we see that the time taken has reduced to 12 seconds, so approximately 10 seconds. That is, even when we have the same limitation of the maximum OS threads limited to 2. In the console, we can see several virtual threads being used, 51, 52, 53, 54, etc. Let's increase the concurrency level to 10. And so with 20 requests, each request taking a time of 2 seconds, we should now expect a time of around 4 seconds. And it is approximately that, 6 seconds. So virtual threads allows us to increase the concurrency of our application and helps us scale, overcoming the limitation of traditional Java platform or OS threads. In this video, we first took a quick overview of virtual threads, and then we saw how to use them in Spring Boot to increase concurrency and scalability. Thanks for watching.